Welcome students to this ordinary differential equation course which is offered in NPTEL platform. I am your instructor Dr. Kaushik Ball, and my email ID, if you want to if you have any doubts, if you want that clarification or any questions regarding the course, you can always mail me at kaushik@iitk.ac.in. So about me, I generally am interested in PDE, that is like partial differential equation and equations, and something called a geometric analysis. So basically ODE and PD, these are very much related to each other, because most of the times there are many PDs which you can actually reduce it to ODEs. Okay, now that is about me, but let's just look at what are the books which you can consult for this course. So the first book which I suggest you is this book called The Theory of ODEs. This is by KANPUR-NPTEL and Levinson, right? And in this book, most of the basic theory, just the basic part where the existence, uniqueness, those sort of things, you can actually get it from this KANPUR-NPTEL Levinson book. And for the other part, so basically the phase portrait part and the asymptotic behavior, stability, and the qualitative theory, you can get it in this Harshansmale book called The Differential Equation, Dynamical Systems and Introduction to Chaos, and also in this book Differential Equation and Dynamical Systems by Lawrence Barco. Okay, these two are very good book, and most of the material which is covered in this course will be in these first two books, A and B. Right, now what is the idea of the course? So basically the idea of the course is to give a detailed picture of basic theory of ODE. So essentially, let me explain to you what exactly I expect you to know. So essentially in this course I expect you to know some basic linear algebra which you are going to use extensively, okay, just the basic one. And then I also want you to know some real analysis, these are the prerequisites, okay, and some several variable calculus. So basically, what is a gradient, how is it related with the differentiation of a several variable function, okay. So several variable calculus, how to find maximum, minima, those sort of questions, okay. So these are the prerequisites which I want from you for this course. Now the thing is, generally in ODE, I am quite sure you know some ODE, okay. So basically in those kind of ODEs, so the most basic ODE courses, what we do is we basically look at some equation. Let's say you are given this equation ODE and you want to solve this equation. So basically you are looking for a closed solution, okay, W, which actually satisfies this equation, and you can exactly write down what W is, so as a function of X or Y, whatever, okay. So you can actually write it down. Now the thing is this, generally speaking, in real applications, what happens is you actually start modeling some phenomena, and once you do that, you actually reduce these models actually turn out to be something like a PD or a OD. Now what happens is, generally for these models, the equations which you actually get are not solvable, okay, solvable in the sense that you don't get an explicit function. And what you do in that case is basically this sort of analysis which you are going to learn in this course. So essentially what we do is, first of all, let's say I give you any equation A equals to 0. The question is this: without solving it explicitly, can you say that this problem has a solution? If there is a solution, can you say that that solution is unique? So that those two questions is the first part, which is called, and this theorem is called a Picard's existence uniqueness theorem. We are going to cover it in detail, okay. And then we'll continue our study to the qualitative theory. What is a qualitative theory? So basically, once you get that there is a solution to this equation, let's say there is a solution W, okay, we don't know what explicitly W looks like, but we know there is a solution W, okay. And once that is, we want to figure out what W does. So basically, what are the properties of W, what is the asymptotic stability, behavior, whether the solution is bounded or not, okay, and if there is a maxima which is attained somewhere or not, this sort of questions, okay. And how many zeros does it have? So basically oscillation kind of thing. So maximal principle, boundedness, asymptotic behavior, and the oscillation theory. These sort of questions we are going to learn in the qualitative theory, okay. And then that will be followed by boundary value problem, where we are going to study the eigenvalue problems, which are very, very fundamental, not only in the study of OD but also in PD and other part of mathematics. And that will be followed by Fourier series, okay, which is again in itself is very important topic. We are going to finish this course with this last part, which is like the asymptotic behavior and the stability of solution. Stability means if you change the initial data in little bit, you expect your solution to change a little bit, right? Okay, so I will explain. The little bit is not very mathematical word, but the thing is you understood, right, what I am trying to say. Basically this is the we will put it in a proper mathematical form, but essentially that's the idea, that a little change in the initial data actually helps you with a little change in the solution. Okay, so that those are the solution stability questions. So we are going to do this sort of thing in this ODE course. So I hope it will be fruitful to you, and let's meet for the first lecture of this course, and thank you very much for registering in this course.